In the video on stacks, I showed how a stack can be thought of as a means for creating undo points and then returning to those undo points. I also said that the big reason for learning about stacks is because they're useful for transformations. In this video, I'll show you why. Let's start with an example. Here's a little sketch that I wrote to show an animated mobile. There are 3 animals here. Notice that all the bars are rigid. We don't have any strings here. We have maybe one string coming down from the top, then there's an upside down U-shaped bar with an elephant at one end, and at the left end there's another U-shaped bar, and there's a duck and a bear. And these things aren't exactly centered because I visually tried to balance the weights a little bit. If you tried to create this animation without using stacks, oh man, you're in for a lot of work and a lot of typing. But if you use the transformation stack, it's really straightforward. In this video, I'll show you how to approach this kind of project using stacks. We'll look at the actual system calls, and then we'll revisit the animation to see those system calls in action. Here's my basic sketch from the mobile, and I'm also showing you where the coordinate systems are for the 3 animals. Both the duck and the bear are looking along the positive x-axis. The elephant is looking into the negative x-axis. So let's use this to draw the mobile. Let's now look at the process of creating this frame from the animation using the transform stack. So as usual, the first thing I'll do is I'll put a piece of tracing paper over the top so we can see what we're doing. And I'll start out with the coordinate system in the upper left in its default location and size and orientation. And just like we did for colors, on the right-hand side of the video, I will draw the transform stack. This is just like the color stack we saw in the video on stacks, only it holds the current coordinate system. This is the active one, and so I'll put a little border around it. What is saved in the stack is the location, size, and orientation of the coordinate system. It's not the picture we're drawing or any of the pixels or anything else. It's just the coordinate system itself. To draw the mobile, the first thing we'll do is we'll move the coordinate system to the top middle of the frame. You can see that the coordinate system moved both in the big picture on the left and in the little version that is sitting in the stack on the right. The version on the right that is active, the one with the blue box around it, always represents whatever we're doing to the coordinate system right now. And of course, the stack has only one coordinate system in it now, so that's the one that always gets changed. So let's draw the picture. First thing I'll do is I'll draw the wire that hangs down from the top. I'll translate the coordinate system down, draw the big knot that holds the pieces together, and then I'll rotate the coordinate system a little bit so that the first bar is lined up with the x-axis, which will make it easier to draw. So we'll rotate it a little bit, and I want to come back to this point. I want to save this. The reason why is I'm going to move to the left to draw all the stuff with the duck and the bear. And then I want to come back here in this orientation with this rotation to move to the right and draw the elephant. So I'm going to remember this spot. And the way I'm going to do it is I'm going to take a snapshot and add that to the top of the stack. Now this is the active system, and the coordinate system at the bottom of the stack is now just saved in memory and it's untouched. To really cement the fact that we've saved this, in the image, I'm going to draw sort of a shadowy version of the coordinate system. That'll be easier to see when we move away from it, and that's to reinforce the idea that we've saved this location. All right, let's continue with drawing. Let's draw the bar that goes through the x-axis, and I'm going to do this fairly quickly now. I'll move to the left-hand edge. I'll draw the bar that goes down. I'll move down to the bottom of that bar, and I'll draw the knot. Now I need to rotate again, so I'm in the right orientation for the duck and the bear. So I'll go ahead and rotate this thing a little bit counterclockwise, and I want to save this again, because now I'm going to go to the left to draw the duck, and then I want to come right back here with this orientation and this location so I can go to the right and draw the bear. So I'm going to save this. Take a picture of it, and now this coordinate system is the active coordinate system. And we can see that because it's on top of the stack. And again, I've put that border around it to really reinforce that idea. And again, I'll put a little shadow version behind it to remind us that we've taken a snapshot of this coordinate system. Now let's draw the duck. I'll draw the bar. I'll move to the left-hand edge of the bar. I'll draw the line that goes down to hold the duck. move down to the base of the duck, and I realize, oh, I have to make the coordinate system a little bit bigger to get the duck to be the size I want. So we'll enlarge it, and we'll draw the duck. And now I'm going to undo. I'm going to go back to the most recently saved coordinate system. All I have to do is throw away the top of the stack. That goes away, and notice the coordinate system returns to where it was when we saved it. Okay, so as far as processing is concerned, this is our coordinate system. So let's proceed. We'll move to the right. We'll draw the bar that holds the bear. Move to the base of the bear. We have to scale it up a little bit, so we'll do that. And now I'll draw the bear. Now I want to draw the elephant. The easiest way to do that is to go all the way back to our first save point, our first undo, and proceed from there. And we know how to do that. We don't have to unroll all of the translations, rotations, and scales manually. All we have to do is throw them all away. We say processing, take the topmost element of the stack, and throw it away. What we're left with is a new top of the stack. Well, the stack only has one thing on it, the current coordinate system, and that has been returned back to the top of the image. So great, let's proceed. We move to the right, we draw the bar. This time I won't go all the way down because I don't want it to show up underneath the elephant. I'll translate down to the base of the elephant, scale up my coordinate system a little bit, and draw the elephant. And now we're done. We have just created this frame of the animation. For the next frame, we'll do exactly the same thing, only the rotation angles will change just a little bit. So I've been talking about saving a copy of the system and then undoing to recover that save. But I haven't named the actual system calls. Let's look at that now. So we only have two operations. The first we can think of as save, or set an undo point. It says take the topmost element of the stack, make a copy of it, stick it on top, and now that is the active system. So that's our save operation. And then we have our undo operation. It says take the topmost element of the stack and throw it away. Whatever is on top now becomes the active system. So that's undo. If I was king of the world, I would probably call these two things something like save coords and undo coords. Now, I'm the first to say that coords is a little awkward to say. It's kind of a mouthful. But I think that these two names very clearly describe what's going on. Unfortunately, these are not the names that we use. We have alternative command names that come to us from the history of mathematics and computer graphics. First, let's talk about save. Rather than the word save, we use the word push. And this makes sense if you look at the picture, and you always think of this visually. Think of pushing a new copy of the coordinate system onto the top of the stack. So instead of save, we use the word push. The opposite of push in this context is pop. Pop means throw away the top element of the stack. And then what's left is the new top becomes the new active system. So now the question is, what are we pushing and popping? And of course, we're pushing and popping the coordinate system, but we don't use that word. We use the word matrix. This use of the word matrix has nothing to do with the science fiction idea of people running around in black leather wearing really cool sunglasses. Instead, it's a word that comes to us again from mathematics and computer science, where we represent the coordinate system with a mathematical idea called a matrix. And we don't have to get into what it is or why it's called that, but that's just its name. And you hear people talk about this all the time. They say something like, oh, make the matrix bigger. And what they really mean is make the coordinate system bigger. So you can think of this as kind of a leftover piece of notation from early days, but that's what it is. And so the two commands for saving and undoing are actually named push matrix and pop matrix. And as you can see, they don't take any arguments. You just say push matrix with two parens, and it does the operation of creating a copy and sticking it on top. Pop matrix says throw away the top element of the stack. And in both cases, what we're talking about is the stack of coordinate systems, which just happen to be represented with this computer science idea of a matrix. In part 2, we'll continue our discussion and see how to use these functions to draw our moving animal sculpture.